I'm going to make two bold claims in this video. The first one is that compaction for LLM chatbots will be disappeared with really soon, and it should be. And second is that figuring out context management for agents is actually enough to get you to AGI. So let me justify this. What is compaction, first of all? If you're talking with Claude or ChatGPT, these AI LLM models, um, I don't actually know how ChatGPT does it, but this is like an agent level thing. It's not something that's baked into the model. It's something that the agent harness implements. So something like Claude Code, that's an agent harness over the Claude model. What does it do? Well, what happens is you're going to run out of context eventually, which just means the conversation gets so long that it's going to forget older content. So what do? Well, the way that Claude Code handles it, and probably the way a lot of other agents handle it, is that they wait until you run out of context. The conversation gets so long that it's going to forget the older content. Then they read over the whole conversation, extract the most relevant and important details, append those to the beginning of a new conversation, and wipe the old data. It's still stored somewhere, but it's not part of the context. And you just continue from there. And there's arguments about whether to do this at all because should you just clear the data? Because if you compact, that's just appending a bunch of kind of nonsense to the beginning of um, of a new conversation, which may not be relevant, and context can be confusing if it's incorrect. So that there's that. Um, for a little while, I was confused. How do you even do this? Because if you have an agent that can summarize the chat, then like isn't you shouldn't be using that agent instead. But there are a few ways around it. Like you can wait until you're near the cutoff before you do it. Then the new agent will have enough space to work with. That's why there's like a compaction threshold. It doesn't compact when you get all the way. It gives you a little slack. That's one thing. Second is you can do it incrementally. You can like have an agent look at parts of the conversation history at a time and summarize them individually. So then you're not feeding in the context all at once. Still, it's kind of expensive. But third, and this is what I think they're likely doing. I'm sorry, there's probably someone who knows way more about this than me, so they're probably getting mad at this summary. But this is speculation. Not that it's a mystery, but I think what they're doing is they're taking the conversation, they're feeding it to a cheap, fast model that can quickly summarize, and it's going to be kind of half baked, but it has a lot to work with, so it doesn't matter. Um, you feed it to a cheap, fast model, it summarizes, and so on. I do this for something similar. The Claude Web Fetch feature, the way it works is it doesn't actually feed the whole website into your conversation. Did you know this? The Claude Web Fetch feature. How it actually works is it fetches the website, converts it into Markdown, so it just strips it out, converts it to Markdown, prunes the DOM tree, so it's just the text, right? Then it feeds it to a small, fast model, cheap model. Then it feeds it into the Claude context. And I'm making a browser extension right now, does something similar, kind of inspired by this. It's page fetch feature to help you with browser extensions, right? So I know a bit about that. Now, what is my point here? Because I made two bold claims at the beginning of the video. One is compaction is not going to last much longer. Second is compaction, once solved, could lead to AGI. Okay, first claim. Why compaction won't last much longer? Well, think of video games, right? We used to have video games, you had to manually save your place. So you could play the video game for a while, or you would load up a new save, you'd play the game for an hour. If your computer happened to crash during that hour, you lose your game state. You don't want that to happen. If you accidentally save over the wrong save, you lose your game state. But if you save at the end of that session, then you have that save, you can come back to it, you can save scum. But that's really like stochastic. Rather than a stochastic approach, shouldn't we do like a normalized thing where, so for another example, it used to be on YouTube, it would like load the video all at the beginning, and you could sit there, pause it, wait for the video to load in, and then you'd have the gray bar gone a lot further, and you could play what was loaded in. That's how it used to work. YouTube doesn't work like that anymore. It's been a long time since I had to load it all. I have a pretty fast internet, but it only loads a little bit in advance, and then your progress bar goes further and further. So YouTube got a lot more performant separately because probably internet bandwidth speeds, 5G got faster, but it loads it in incrementally. That's the main difference. And modern games, if you play Assassin's Creed, this was true even like 2016. They auto save, or depending on the save mechanism of the game, they can do it differently. But that's a gameplay feature. It's no longer something about like they don't have the capacity to save. No, there are engineers who know how to incrementally save, so it auto saves for you. I think there's something similar with compaction, where why does it wait until the very end of the conversation to compact? Why doesn't it just compact as you're working? It like runs the main model, then there's another side model which is like summarizing it as you go. And even you could even go back and revise the summary if other facts become more important. It can do that. So just compact as you go. I think there are tools to do this. They're like cloud plugins. It's not the norm. Everyone still uses. Maybe I'm the crazy one. Maybe no one else is using compaction. I'm still compacting everything. I don't know, guys. I'm compacting like it's 2025. Um, anyway, well, it's normalized so that by the time you reach the end of the conversation context, you don't need to like feed it to a model, wait for 2, 3, 4 minutes to do that. It's just right there. You can continue where you left off, and there's a little notification saying, "Oops, just so you know, you passed the threshold. There was some compaction that went on." But why don't we take it further? Why do you need that notification at all? Why doesn't it just edit the history as you go? So this is getting. I don't want to bury the lead, but okay. Humans. How does human memory work? In your head, you only have like a few thoughts in your working memory at any given time. You have thoughts bouncing around, a thought from, an hour ago, you remember something you did last week. Maybe sometimes you remember something that happened like years ago. Sometimes you remember something that happened when you were 10 years old. And as you go further and further back, the frequency at which you recall those details decreases. But it's not a discrete curve, it's a continuous curve. It gradually, as time goes on, the frequency at which you remember those things goes down. But that's why human memory has to work like that. Because you don't just want to remember like any arbitrary number of irrelevant details that happened when you were 10 years old. You want it to slope down like that. That's why you have these concept of forgetting curves. Well, forgetting curve is just a feature. It's just a forgetting curve that people who study like memory composition, studying for exams, use Anki flashcards, they know very well. They forgetting curves. Well, it's a feature. It's just an algorithm for your brain to figure out the frequency of which it should recall certain details. Otherwise, it's gonna pollute uh, the memory context. Context engineers, they know this well. If you prompt the agent too much and it's like you're talking about something irrelevant, suddenly you have it work on an unrelated feature, the coding agent is going to be confused. It's like, it's not that bad, but you're just wasting context. Okay? The brain works like this, it doesn't want to waste context. So it has some sort of algorithm or process for recalling, events that happened in your life into your working memory. And what is an idea? What is an insight? An epiphany is when you have a few ideas that are like related to each other. Your unconscious mind knows to recall them into the conscious mind to make that connection. And you're like, oh, wait, these things are the same. And then I have an idea. I'm going to do that. And if you have a great idea, I'm going to make this business. It's you're combining a few ideas that you had in the past, right? And it's don't get hung up on terms like memory versus idea. It's all the same. It's all like things that are in your brain, right? It's all being recalled. It's context. Um, but the working memory that humans have is so small. It's nothing compared to these million context LLMs, right? Um, I think the reason why they have limited context is because it's not because they can't in theory do inference for more than that, but they can't do inference for that because in order to for that to be viable, they need to train on context going far back. And as you train on it, you need to compute that, and that's the expensive bit. I think the bottleneck on having larger and larger context is the training time bandwidth in like how much uh, you can store in the GPUs or across the GPU cluster, as opposed to the inference time. But I think that's the bottleneck. I could be wrong. But anyway, yeah, there is this bottleneck. You just can't scale up the context length that much because in order to compute the way transformers work, it takes the well, I'm not going to explain the linear algebra, but you get the point. It's like n squared, right? The context length. So it's non-trivial to compute. The three blue one brown video explains this pretty well. But I separately read a bit about transformers and how they work, and it's difficult to train that. But okay, here's the proposal. Um, Human brains, they have very short context length. The thing that superpowers the human brain is the algorithm for like recalling the details. So, what if the context, instead of just being like text context, it was like an index, a database of messages, an ordered database of messages. And it's like you could represent this as a linked list so that you can easily insert messages, remove messages. You have two agents. You have the worker agent, which is using that database of the last, I don't know, 500 messages as its context. That's the worker agent. Then you have the summary agent. The summary agent, it's working nonstop. Its whole job, you could even have a cluster of like a bunch of agents. You could spin up 100 agents to look through every message you have ever sent in the history of this entire conversation. You have like 100 small agents that are reading it, comparing it to the present context, trying to see, is this message relevant? Is this message relevant? Is this message relevant? And as you work, it's constructing the perfect context for the model. And in theory, that should work, right? Because every time you prompt the agent again, you're only appending it's like a new prompt. Maybe the models, they have like a caching layer or something so that like the network requests are slower or faster. But in terms of the model, it's just a next token predictor. So you can manipulate as much as you want the uh, historical context. So why do we not do this? Why do we not have worker agents which are like reordering and uh, they could even add information. They could do web fetches as we speak to insert like representative context. We already sort of do this because what is like thinking mode? What is spinning up subject agents? What is research agents? They are trying to help the model by constructing more and more context by appending that to the end. But why just append that to the end? Why can't we just store a linked list of all the messages in the context and construct the perfect context for it by inserting it at arbitrary points, researching the entire history of the conversation. This is so fascinating. Um, Compaction is just the wrong primitive, and there is already widespread acknowledgement of this. Uh, there are agent harnesses that outperform the compaction over long time spans, and the way they work is, and there's some research papers about this. The way they work is they store the whole context in memory in a REPL, and they give the agent access to tools to just query the memory. They just store it as a big string, and they let the agent run any arbitrary tool command against that string. In practice, what it's going to do most of the time is um, grep the string. So as opposed to like doing the compaction, these alternative systems that have been proposed in research papers and theoretically demonstrated to work superior, they just grep the context. You just give it tool use protocols for grepping the context. That's all you need, and that heuristic alone is better than compaction. But that's a different thing. I'm saying step one compaction. Step two is these grep tools, which you use to search the context. Not the context, the full time conversation. Um, I'm proposing like step three is these asynchronous subagents that are continuously reorganizing the context, and that is actually analogous to the human brain. Is that going to get us AGI? Well, I think it can get us AGI because this is the main limitation on these agents right now, right? They have no coherency. Coherency is the perfect word. Um, Sorry if I'm being sloppy with all my words. I'm like, not this is not scripted or anything. So I hope I'm being somewhat uh, coherent. I hope I'm making any sense at all. But I think this is exciting Um, if it was in the news like the last week, it was Multbook, this Reddit clone for agents to protect. There's a whole drama with that, but you see like some of the shenanigans the agents get up to on Multbook, and they're like trying to simulate redditors, and it's so funny. They're trained on redditors, so they do a great job like parroting the stupidest redditors you've ever seen. But you see some of these posts on Multbook, and they're like, we're going to found a religion. We're going to establish this new protocol. We're going to create a technology. The agents can't do this, not because they're not that autonomous. You can put it in an agent harness, but because they have no coherency. The agent is going to plan this one thing because it's trying to simulate Reddit, and then it doesn't have context with length that much. A day later, it will have long forgotten that. If any piece of that survived the context compaction, is that enough? Probably not, right? That's not reliable. It would have had to like write the plan to a file and like reread it or some complex thing. Just the agents lack uh, at a bottom level, fundamentally um, the coherency that humans have. And when I go to my job, I know that what I have to do, how to prioritize. I have to prioritize this subtask, but there's an underlying organizing superstructure which decides what is the subtask. You know, um, if an agent can do that, and there's no fundamental limit to that, um, I don't know if we're gonna find like a way to actually get infinite context length in the fundamental model weights in terms of what's being processed by the inference itself. That could be a hard limit on scalability, is the context. But the agent harness, that's in a world of infinite possibilities. You can do whatever you want there, and it's just self-evident that the current batch of agent harnesses that have been being built is only iteration one. Cloud Code is super buggy. All these other tools are super buggy. It's because these are tools that people built in the 3 months after Opus 4.5 came out and these became viable. So I think we have a long way to go, and if we figure this out, that's gonna bring us much closer to how intelligent systems in their fullest capacity could theoretically work. So I think that's pretty exciting.